Okay, so remember that yesterday, well, we didn't actually finish J, did we? We found I just realized that. We found the derivative, and this is what we simplified it to, but then we were also supposed to find f prime of 3. And so that is going to give me negative 1 over 3 squared plus 4 times 3. Okay. So that gives me negative 1/9 plus 12. Right? Then what do we need to be able to add those two? Common denominator, and my common denominator would be 9. So I'm going to make this into something over 9. 9 times 12 is 108. Good. And I probably wrote way too big and should have written this down here. Oh well, I'll write this down here, even though you can't. So then when I do that, that will give me 107 over 9. Okay. 108 minus 1. We good? Yes? Okay, perfect. All right, so actually I'll probably still do it here because we don't need much room for L once we get there. All right, so we rewrote K so that it looked more like this and we didn't have any in the denominator anymore. So when I want to find f prime of x, okay, I multiply, so this gives me negative 2x to the what? Negative 3, good. Don't let those negative exponents mess you up. Remember that you're subtracting 1 because that's where a lot of mistakes happen. Then I'm going to multiply negative 3 times negative 2, that's positive 6, times x to the what? Negative 4, plus, what's the derivative of 3x? 3, right? Because that's like a 1, so then 3 times 1 is 3, and then that would be x to the 0. And then what's the derivative of a constant? 0, so I don't need to put anything, so I'm just there, okay? Then I want to put it, so again, this would be a safe stop if we were done, but if I want to evaluate it, I don't want negative exponents. So this is also equal to negative 2 over x cubed plus 6 over x to the 4th plus 3. Okay, we agree with that? And that's going to be way better. Be careful with when you're doing this stuff that you don't like try and turn this into a negative 6 or something weird like that, that the negatives on the exponent don't change the values like or the signs on the numbers or anything. All right, so now that we have that, I want to find f prime of 3. So that's going to be negative 2 over 3 cubed plus 6 over 3 to the 4th plus 3. Okay, now, before we multiply anything out, let's think smarter, not harder, right? I'm going to leave my denominators to the powers like this. I'm going to show you how this can help you. I'm going to make my common denominator 3 to the 4th. Not whatever that value is, just literally 3 to the 4th. Okay? So when I do that, that means if this is going to become 3 to the 4th, I have to multiply by 3 over 3. Yes? So I get negative 6 over 3 to the 4th plus 6 over 3 to the 4th. Do I even care about the last part being a fraction? No. If I just put plus 3, what happens with these two? They zero out, and my answer is 3. I didn't have to get crazy big common denominators. I just understand how numbers work. And honestly, when the first time when I did that, and I was like, I'm going to work it out this way, I didn't even know that was going to happen. But it did. But even if it didn't, it still might make things easier. Yes? You could have done that. Absolutely. Yes. Absolutely. Right. So right here, you could have, he said, instead of getting a common denominator, but with fractions, my brain always goes to common denominator first. But yes, I could have taken a 3 out of this to make it 3 to the 3rd and a 3 out of this to make it 2, and they're still going to zero out. Absolutely. So that's why it's good to kind of look at what you have. I mean, you don't want to spend forever overanalyzing it and looking for the easiest way. But if there's something like that that you see that maybe I've got some 3's in that problem that maybe something might cancel out. I was even assuming maybe I'd have to do the last one and then I could put them together and then maybe a 3 then would come out. Who knows? But we okay on that? All right. So this is all crammed together because let's look at L or I, whatever it's L. F of x equals pi cubed. Now, your first instinct might be to multiply 3 times pi and to get 3 pi squared. But that's not what we're doing here, because back up here, this only works for powers of x. And x has to be in the base. I don't even have an x there. Right? Now, if it was y or something else, I mean, we could do that too, but I don't have a variable. A variable varies, right? I can substitute all kinds of different x's into this f of x and get something out. Does pi always have the same value? Since it always has the same value, it is constant. Pi to the third is just a number, some number, right? That's going to be a little bit more than 3 cubed, right? It's probably in the 30s somewhere. But so it's just some value. So then what is f prime of x? It's just 0. This is just a constant, and just like here, when we took the derivative of -7, it was just 0. We didn't even write it down. The derivative of that is 0. So then, what is f prime of 3? 0. Okay, that's a little tricky, I know. But the pi's and the e's, you have to remind yourself sometimes they're just numbers. It's not an x where I can substitute. It's just pi. Pi is pi. Okay, we good? Okay. Because this graph right here, this would just be a horizontal line, right? At whatever pi to the third is. That's all it is, because it's constant. All right, so let's flip this over. Now we've got radicals, okay? All right, so in calculus, we will always turn radicals, meaning the square root signs, into, radicals into power form, I guess. So as a little reminder, the square root of x is the same thing as x to the 1/2 power. So in general, the nth root of x can always be written as x to the 1/n power, meaning that I can do anything. If I have the third root of x, that's the same as x to the 1/3 power, right? Fifth root is x to the 1/5, and so forth and so on. Okay, remember that? Yes, yes. Okay, so let's look at what we're doing here then. We want to find g prime, or we're given g of x, we want to find g prime and g prime of 5. So the first thing I'm going to do is I'm going to rewrite this as x to the 1/2 power. So then g prime of x equals, I use the exact same power rule we've been doing. I multiply the 1/2 into the front, so I have 1/2 times x, and then I subtract 1 from the exponent. When I subtract 1, what am I going to get? -1/2, right? Everybody okay with that? So isn't this the same thing as -1/2 over 1? Like I could just put this over 1. Like that's the same thing, right? You don't have to put it, but it is. We'll go ahead and put that so we know. So we could multiply this and say that it is x to the -1/2 over 2. 2's in the denominator, right? But doesn't this -1/2 just means that that goes in the denominator? So that means that this is 1 over 2 times x to the 1/2 power, which is 1 over 2 square roots of x. Now, you could leave it like this, or you could skip this step and do this. Just like with having positive exponents, I would suggest that you have roots when you are going to substitute something in, so you don't do weird things with fractional roots, because with the roots, I think it makes, fractional exponents, I think the roots make more sense. Everybody okay with where that came from? And this, you'll have to do this kind of thing a lot, and you'll get a little quicker. You don't have to write every single step, but so now I need g prime of 5. So that's equal to 1 over 2 times the square root of 5. And that's it. You're done. You don't have to rationalize anything. You can. Like, oh, this first step? No. You should never leave a negative exponent. Yeah. Never leave a negative exponent. Everybody okay with that? And we don't have to rationalize. Just leave it. You're fine. Okay. We good? All right, so let's see. We've got this negative 3 times the square root of x. So this is going to be equal to negative 3 times x to the 1/2 power. It's not the derivative. I'm just rewriting my original function so that it's easier for me to handle. Now I'm going to find g prime of x. That's equal to. So now I'm going to take this 1/2. I'm going to multiply it by the negative 3, so I get negative 3/2. Then times x to the what? Negative 1/2. Good. Negative 1/2. So then I can rewrite this as, I know I have a negative 3 in the numerator, a 2 in the denominator, and then that square root of x goes in the denominator as well. We good on that? Where everything came from? Yes? All right, so then I want g prime of 5. That's negative 3 over 2 times the square root of 5. What questions you got? We good? All right, let's look at this 1/3. So this would be 5 times x to the 1/3 power. So g prime of x is equal to, I multiply 1/3 times 5, that gives me 5/3, times x to what power? Negative 2/3. Yeah, because I'm subtracting 1, so that gives me a negative 2/3. Yes? So we're going to write this in 2 steps here. This gives me then, I know I have a 5 in the numerator, 3 in the denominator, and that would be x to the 2/3 power. But I need to know, I need to rewrite that in root form. How do I write 2/3 power as roots? Cube root, so this is like 2 times 1/3, right? And if there was just a 2, that'd be squared. If it's just a 1/3, it'd be the cube root, right? So that means that this is going to give me 5 over 3 times the cube root of x squared. Sorry, I'm a little close there. Okay? Separate the fraction from the numerator, and then you can get your root and your squared. Okay? We okay with that? All right. So then I want g prime of 3. No, 5. 3 was on the other side. 5. This is going to give me 5 over 3 times the cube root of 5 squared. Can I cancel out any 5s? No, because this one's living in a root, and he's inside the house, so you can't find him, and so you can't do anything with him. You can do something with him, but you can't cancel those out. So I can then do, that's equal to 5 over 3 times the cube root of 25. And since I can't find the cube root of 25, just like when I couldn't type the square root of 5, I'm done, and that's my answer. Okay. What questions do you have? Anything? All right. So now I'm going to break you up into groups, and you're going to do the rest on your own. Okay. Go through them together. So the first thing you do is you have to get the variables out of the denominator. Okay, so this is equal to 4 times x to the negative 1/2 power. Do we agree with that? Yes? Okay. So then my g prime of x is equal to, I do negative 1/2 times 4, that's a negative 2, times x to the what? Negative 3 over 2, or negative 3/2, right? Okay, so then when I simplify that, that's going to become negative 2 in the numerator. Since I have a negative exponent, that x drops to the denominator. Is it a cube root or a square root? the square root of x to what? To the third power, okay? Now, not that you would have to, but just so you know like how this works before you do things, could you simplify that square root? Yes. This square root, this is the square root of x cubed. So that's also the same thing. This is totally fine to leave it like this, and we would, but there's reasons you need to understand how to do these things. This is the same thing as x times the square root of x. Oh. And here's why. Let me show you why, okay, since we're not doing the other part. If I have negative 2 over x to the 3/2 power, okay? That's basically what we had, right? That's the same thing as, isn't this 1 plus 1/2? So this is negative 2 over x to the first times x to the 1/2 power. Because 1 plus 1/2 is 3/2, and so then that can turn into that. You can kind of look at it in either direction. It is fine to leave it like this, but again, if you have, there's reasons you might need to simplify or whatever and just kind of understand how the things work together. Okay, we good with that? Okay, perfect. All right, so let's look at g. I need to rewrite this. This becomes 2 times x to the 1/5 power. So I multiply. I want g prime, so I'm going to multiply 1/5 times 2. That's going to be 2/5 times x. So if I take 1/5 minus 1, what does that give me? Negative 4/5. Yes. Okay. So then that is going to be equal to, I have a fraction, 2 in the numerator, 5 in the denominator. Is this going to be a 4th root or a 5th root? 5th root. 5th root of x to the 4th. Can I simplify that one? The answer is no. And here's how you know from the fractional exponents, or if you have a root, you can think about the fractional exponents. This fraction was greater than 1. That's why I got to pull 1 out. This fraction is not greater than 1, so then I can't, and then that's all I can do. Okay? Does that make sense? Just making sure you know how to look at these things. All right, so this one we had a little equation, or I'm sorry, two terms in our equation, all of them are equations. We have the x to the 1/3 power, right? Minus, and then this would be x to the what? Negative 1/4 power. We okay with that? All right. G prime of x equals. All right. So I'm going to take 1/3 out the front times x to the negative 2/3 power. We agree with that? Negative 1/4 gets multiplied by that negative x, so that gives me a positive 1/4 x to the what? Well, I have negative 1/4 that I'm going to subtract 1 from, right? Negative 5/4. So what'd you say? What do you have? You have a question? Okay. Well, think of it this way. Whether either we're like adding or subtracting, if you have fourths, let's just have a little fraction lesson because you get it right in your brain. If I have a fourth, I want you to literally think about what it looks like you did in kindergarten, right? I have 1/4. If I subtract 1 from it, then I'm getting the rest of it, and it would all be negative. Like, think of it in the pieces. So a whole thing is 4/4. You have 1/4 minus 1 will give you 3/4, right? So if I do 1/4 minus 1, it's just like doing 3 minus 2 or 2 minus 3. You're still subtracting the same way, but the negative goes in a different spot. Does that make sense? So don't make it harder than it is. Just think about it. It's still just subtracting or adding. In this case, we're adding, though, because, and if you think of a number line, because I understand that these kind of things can trip you up, and I don't want this to be the reason we can't do things, right? So if you just picture a number line, you don't have to draw one out. But you're already here, like here's 0. You're already here at negative 1/4. You're going to subtract a whole 1. So you're getting, it's going to be over here. You're getting more negative. So since I'm subtracting 1, I'm really adding the 2 values. And that's why I would add 1 to this or add 4/4, which gives me 5/4. Does that make sense? Does that help a little bit? See, it pays to speak up. Oh, no. Maybe it pays until I mess something up. There we go. I hit the wrong thing. right, let me get rid of that. Okay, so with all that said, then let's finish this one up. So this is going to give me, I'm going to have my fraction, my 1, and my 3's down here. Is this a third root or a square root? Third. Am I going to be able to simplify it? No, because the fraction's less than 1, right? I don't have 1 to pull out. So this is a cube root of x squared. Plus, then I have 1 and a 4th. Would I be able to simplify this one? Yes. We're not going to, but I just want you to understand why we could, because I could pull the 1 out since it's greater than 1. Is this a 4th root or a 5th root? 4th root. So it's the 4th root of x to the 5th. Or it could be x times the 4th root of x, but we don't have to. Just throwing those little things in as we come across them. How do we feel about that? Did we do well if we got to F? I know some of us didn't get to F. And I realize now, I thought I had kind of done one of each, and I realize now why some of you were so stuck on D, because I hadn't done one where you had to get out of the denominator. We were only putting it in the denominator. But so some of you got stuck there. But are we good on that? Got the derivative? Okay. Here's the good news, is most derivatives that you do aren't going to be crazy weird like this, but they do pop up every now and then, so we have to know what to do with them. Okay? But most of them are pretty straightforward. Okay. So here we go. This is going to be x to the what power? 3/2 or 2/3? 3/2. Good. X to the 3/2 power, because the root's the denominator, right? So then we have g prime of x. I multiply 3/2 out in front, and then I get x. What's 3/2 minus 1? 1/2. And then that just gives me, I make my fraction 3, 2, oh, shoot. I have a 3 and I have a 2, but then the square root of 2 actually goes in the numerator, so it looks like that. We okay with that? Any questions about where anything came from? What did I do? Oh, God, why do I keep putting a 2 instead of x? I don't know. X. So, thank you. See? Good. Good on you paying attention. I'm sorry. Oh, you could put it as 3/2 times the square root of x. It is better for you and safer for you to put it in one fraction. Like, that's the form you're going to want to do. If you did it the other way, it would not be wrong. But for reasons of what we're going into with this stuff, I highly suggest we do it that way. Okay? That's a very good question. We good? Okay. So this one then, we got to do something we did yesterday as well, which is take the 5 out of the denominator. I'm not going to make it 5 to the negative 1 power, but I can make that 1/5, right, times x to the 1/2 power. We agree with that one? Yes? No? Speak up. Okay. All right, so then I need g prime of x. So I'm going to multiply 1/2 times 1/5. What is that? 1/10. Yes, multiplying fractions is easy. Okay? Times x to the what? 1/2 minus 1, negative 1/2. All right. So then I've taken the derivative. Now I'm going to clean it up. I got my fraction, 1 in the numerator, 10 in the denominator, square root of x in the denominator. Okay, we good? What questions you got? Because it was a positive 1/2, and that was a negative, yeah. I made room in the denominator because they were all in the denominator. I was like, nope, that one goes in the numerator. Okay, we good on that? Good questions. All right. So this becomes negative 2 times x to the 1/2 power plus 3. Yes? So then g prime of x equals, I take 1/2 times negative 2, what's that? Negative 1 times x to the what? Negative 1/2. What's the derivative of 3? 0. So that's really like plus 0. You don't have to write that, but I'm going to write it for you. But you wouldn't have to write that. But I want you to understand we didn't just forget to do it. And then I want to clean this up. So this is just going to be negative 1 in the numerator square root of x in the denominator. Okay. We have time to do one more. I will do the other two like in a little video if y'all want to. I'll finish this video if you want to fast forward to the end. But you want to do okay? Okay. I think we have time. We have time to at least start it. If we don't finish it, then. So I'm going to rewrite it first. I don't know if I have room here. It's going to be x to the negative 1 power minus x to the 1/2 power plus 5x. All I'm doing is rewriting that. Okay? Which I could have rewritten it underneath it, but I didn't want to get it. Everybody with me on that? Okay, so we're going to do g prime of x. That's equal to. So negative 1, I multiply out in front, and I get negative x. What does my exponent become? Negative 2. I take the 1/2, multiply it in front, I get negative 1/2 times x to the what? Negative 1/2. Then this is like an imaginary, not imaginary, but it's an invisible 1. 1 times 5, so this is just 5. Do I do anything else? No. Okay, it's just 5. So then this becomes negative 1 over x squared minus, set up my fraction, then this x to the negative 1/2 ends up down there, and then plus 5. I'm going to give you this worksheet. There's a pink binder over there on the podium. I will put, it may not be pink anymore because I'm going to change it, but there'll be a tab in there that says calculus, so that's where the key will be. You can come check yourself anytime on a worksheet. I think I'll just have one binder instead of two for the two different classes. But I will go back and do those other two. We just don't have time today. So you could watch like 2 minutes of a video if you wanted to. Or we may have time now. I don't know. We'll wait.